Welcome to this presentation. My name is Steve Bartlett, a technical marketing engineer supporting HPE Aruba switching. And as you can see, this is part of the AOS-CX 10.12 update. And this one's EVPN VXLAN with multi-tenancy and VLAN translation. Now, VLAN translation is now supported on the stated platforms here, with VXLAN EVPN also configured on the switch. The features do remain separate features as they are not dependent on each other, but the features can now be deployed together on the same switch, which gives an additional degree of separation at the edge of the network. And this is the agenda: an overview of the feature and its capability, followed by some use cases, details, caveats and configuration items grouped together on item number 3, followed by some scalability and performance characteristics, and then to finish off, show commands and diagnostics. The overview. So what is it from a networking perspective? Tenants can share the same network resources, in this case overlapping VLAN numbering schemes, while keeping those tenants isolated from each other. VLAN translation can assist in maintaining traffic isolation on the same VLAN network amongst different tenants, customers' business areas using the same and overlapping VLANs, and thereby isolating traffic at the tenant edge. A key point to remember though is that the VLAN translation feature does not increase the capacity or the capability of the switch to support additional VLANs. The maximum available VLANs will still be dictated by the number of VLANs available on that platform and used with the number of VLAN translation rules available. The primary use case is within the data center and to be used with VXLAN, but the feature can be used without implementing VXLAN, as it is deployed as a locally significant configuration on the interface port, as you will see. VLAN translation, campus VT versus multi-tenancy VT. VT, as it's commonly known for VLAN translation. So VT is already supported in other AOS-CX platforms, but not with VXLAN EVPN implemented, which is the step change for this specific implementation impacting the data center switch portfolio. However, it does behave in exactly the same way, a bidirectional VLAN rule that maps an external VLAN ID to an internal switch VLAN ID. However, in this implementation, the naming convention changes. So with Campus VT, we have an untranslated VLAN ID known as the external VLAN ID, and the translated VLAN ID known as the internal VLAN ID. Now this changes with this implementation on the data center switch portfolio with multi-tenancy VT. The untranslated VLAN is known as the ingress-egress VLAN, and the translated VLAN is known as the device VLAN. The implementation adheres to the following very simple principles. On the ingress path, the VLAN translation is performed as soon as the packet enters a port. This is before layer 2, layer 3 ACL policy configurations, etc. are enforced on the packet. Post VLAN translation, all the switch functionalities operate on the translated VLAN, which is now known as the device VLAN. Conversely, on the egress path, the VLAN is translated back to an ingress-egress VLAN late in the life of a packet. So, for example, if a packet on a device VLAN of 1000 is about to be sent out on port 111, the VLAN on the packet is translated to, say, VLAN 10 just before port egress. This ensures that all functionalities operate on the device VLAN throughout the life of the packet on the data plane. So from a configuration perspective and functionality perspective, the device VLAN is just like a regular VLAN. All features and configurations are performed on the device VLAN. Use cases. So a use case, the design of the feature is for data center switch platforms for it to be used with EVPN VXLAN. This is to assist in extending separation and flexibility of VLAN deployments with overlapping tenant VLANs all the way to the edge of the network at layer 2. In this example, we've got multiple tenants. Tenant A and Tenant C have overlapping ranges, and Tenant B and D have overlapping ranges. And this deployment is absolutely okay if those tenants do not wish to share the same broadcast domain and do desire separation at the very edge of the network. So as a point, using VLAN translation does not change the performance functionality or capability of intra-fabric and inter-fabric VXLAN connectivity models. The regular VLANs can reside on the same interface as the VLAN translation rules, whether it be an interface port trunk or a lag. And to take an example of a VLAN translation rule, VLAN 30 on the ingress VLAN is translated to VLAN 1000 as the device VLAN, and that VLAN 1000 is then mapped to the VXLAN or the appropriate VXLAN. In this case, the example is VXLAN VNI 10,000. Again, the device VXLAN mapping as a layer 2 VNI or layer 3 VNI is independent of the VLAN translation rules and is not impacted by the VLAN translation rule or the absence of it. So another use case, two-tier layer 2, layer 3 campus or DC. Although this is not the primary use case, the VLAN translation rule can be used on the appropriate switches without VXLAN configured. So if you've got the similar identical requirement tenants or business units that do require separation of overlapping VLANs at the network edge, then VLAN translation can be applied. So it will work in an identical way. We can use VLAN translation without VXLAN. The ingress-egress VLAN is mapped to the device VLAN, but those device VLANs are not mapped to any particular VXLAN VNI. Alternatively, device VLANs can be mapped to VXLAN VNI, providing obviously they're not overlapping with those device VLANs that do not wish to be part of a VXLAN configuration topology. So some use case detail. So we have this concept of multi-tenancy support based on full VNI decoupling, and there's lots of different use case scenarios that you can have. So in this example, in the top chart here, we've got different ports but with the same ingress-egress VLAN, but they're mapped to separate device VLANs and a separate layer 2 VNI. And on the table below, we've got different ingress-egress VLANs, but they are mapped to the same device VLAN. So remember, this is the broadcast domain, the device VLAN. So this would only particularly be practical if they're using the same subnet range, or they could have a secondary IP subnet address on the device VLAN, for example. So lots of flexibility. But so what it does give us, we've got this decoupling from the ingress-egress VLAN, which we can have as an overlapping range to a virtualized environment, for example, to the device VLAN, which is decoupled from the ingress-egress VLAN ranges. And that is then effectively decoupled from the layer 2 VNI, because you then have to manually map that to your layer 2 VNI for your particular tenant. Now on to details, caveats and configuration. So more detail to go through. So these are some of the rules and guidelines. So on interface 111, we've got ingress-egress VLAN 10, map to device VLAN 1000, map to layer 2 VNI of 10,000, that's valid. On 112, we've got a different ingress-egress VLAN 30, mapped to the same device VLAN and the layer 2 VNI, that's valid. 113, we've got an ingress-egress VLAN of 30, mapped to a device VLAN of 3000, and a different layer 2 VNI of 30,000, that's valid. But the rule is, you can, on the same interface, you can only have one ingress-egress VLAN mapping to a device VLAN. So you can't map a different ingress-egress VLAN to a device VLAN that's already got a VLAN translation rule on the same interface. The configuration will kick out an error in the configuration editor. So you can't do that. Of course, you can, on a different interface, do this mapping. If it's 116, 40 to 3000, that would be perfectly fine, and it would have to go to the same VNI, but that would be good, but not on the same interface. Some additional details. So VLAN translation, as I mentioned earlier, is applied on the interface. It is the first function that occurs, which means the broadcast domain on a translated VLAN is the device VLAN. VLAN ACLs are applied to the device VLAN along with any COS policies. So port-based ACLs and QoS can be applied to the interface as usual, but from the device VLAN perspective, this is the VLAN that is consumed within the switch, and all configuration is applied if using VLAN related configurations. On to configuration. So configuration wise, the VLAN translation command is applied within the interface context, either directly under the interface or underneath the lag configuration. So the first VLAN ID is the translated from VLAN. So this is the ingress-egress VLAN, and the second VLAN ID is the translated to VLAN ID, which is the device VLAN. Very straightforward. And if we're looking at the interface configuration as an example, in this case, we've got a VLAN translation rule from 30. This is the ingress VLAN translated to the device VLAN 10. And on the VLAN trunk allowed list, we only need to have the ranges of the device VLANs, which is the translated VLANs. We do not need to insert the ingress-egress VLANs, the untranslated VLANs, on the trunk allowed list. And this is a summary of the activity configurations before it goes into the pipeline. We've got the VLAN trunk allowed list reflecting the translated VLAN ranges for the VT rules used. Packets get translated to the device VLAN and then enter the VLAN pipeline. So from that moment, it is actually business as usual for the device VLAN. So for the translated VLAN, the device VLAN, if there is a VNI association on the switch, then the packets will get encapsulated with the VXLAN. So in this example, there is our device VLAN 10 is mapped to VNI 2000 for this device VLAN 10. It's always the device VLAN that gets mapped to the VXLAN VNI if you're using VLAN translation. And just to highlight, if there's a range of translation rules, you need to have them manually inserted. You can't do ranges, so you have to have an individual statement for each ingress-egress VLAN mapping to the device VLAN. As part of the configuration, there are some points to note. So for the 8325, 9300 and the 10,000 series platforms, all the VLANs in the trunk allowed list are honoured even if they do not have a matching VLAN translation rule. So if a VLAN is part of the allowed list, it will be forwarded. However, for the 8100 and the 8360 series, be aware that the VLANs in the trunk allowed list will not be honoured other than those VLANs that are specified in the translation rule list. So packets that are VLAN tagged other than those specified in the VLAN translated rules will be dropped. And this is just as for part of 10.12. So there is a workaround. This is to map the VLAN translation ingress VLAN to the same device VLAN ID. This of course consumes another VLAN translation rule, but it is a workaround for now. So it is something that we are looking to change in future releases. Caveats and considerations. So the multi-tenancy with VXLAN content I've shown to you, the examples relate to the 8100, the 8325, the 8360, 9300 and 10,000 series platforms. Do note this multi-tenancy with VLAN aware bundle configurations are not supported. This is with VXLAN, and the ARP suppression support with EVPN with multi-tenancy is not yet validated. Support is beta only for 10.12. It does work, I've tested it in the lab, but we haven't yet tested at scale, so we are still considering this as beta only. Multicast protocols are not supported as part of the first release, being 10.12. Recommendation is not to configure VT on the ISL link. It is not needed, so please don't do it. You may get some unforeseen behaviors. So just to highlight that. VLAN translation is only supported on trunk mode. That's layer 2, that's interface physical or lag interfaces. The original VLAN ingress and egress present in the VLAN translation rule should not be mapped to a VNI on the 8325 and the 10,000. It should always be the device VLAN, but if you're using VXLAN and VLAN translation, you should always be mapping the device VLAN to the VXLAN VNI. And just to call out this last item here, multi-tenancy on any native VLAN is not supported, so do be aware of that in your configurations. Continuing on, caveats and considerations. So VLAN translation configurations with VXLAN and the translated traffic flows, local tunnels, all support on all topologies, symmetric IRB, centralized gateways, bridging with VXX configurations, etc. is all supported apart from the highlighted caveats. So Q&Q and VLAN translation, mutually exclusive, along with PVLAN and VLAN translation, that is also mutually exclusive as features. Now moving on to scalability and performance. These are the scalability and performance figures for the selected platforms. As you can see here, the number of maximum VT rules, the VLAN translation rules on the right here. You can take those in and read them at your leisure. So do note this, on the 8360 series, that's both for both V1 and V2 series, when sub interface is configured, the scale for VT rules is reduced to 2,976. So that is 4,000 minus 1,024 rules, which are reserved for the sub interface feature set. So capacity commands, very simple. So we can get the show capacity status or show capacity status with VLAN translation. Will show which VT rules are being used. On to show commands with some troubleshooting diagnostic commands thrown in at the end. So let's look at the show commands, very straightforward. If we use a show VLAN translation, this provides all the rules that are applied on the switch. VLAN 1 being the ingress egress VLAN, VLAN 2 is the translated 2, which is the device VLAN. And we can also use that command in a bit more granular form per interface. And there are some other output to watch out for. So if we see the VLAN translation pending message, it's referencing rules not provisioned to a port. So this will relate to a VLAN translation set of rules or a rule that have not made it into the ASIC as a result of exceeding that switch VT rule capacity. So if you have a selection of rules, say 10, that are about to be pushed or applied to a specific interface, and those rules exceed the switch capacity by 1, then no VLAN translation rules would be applied to that interface. In normal operation, the show VLAN translation pending command will display the no pending rules. So troubleshooting and debug and diagnostic commands, I just wanted to put this in just to highlight that if you're using VLAN translation and you want to debug on a particular VLAN, it's always going to be the device VLAN. So that doesn't change, nothing changes. You start using the same switch capabilities for debug and diagnostics that you already have for standard VLANs. So I just wanted to highlight that. So nothing changed. This is business as usual for device VLANs and regular VLANs. And that brings us to the end of the presentation. Thank you for tuning in.